Hi, this is Summer, my CP8. So here I need to perform deep learning on diabetes data. So here I have imported all the necessary libraries from TensorFlow. Here is the diabetes dataset. It consists of 767 rows and 9 columns. So we are splitting the dataset into training and test with the test size of 25%, and I'm performing feature scaling using standard scaler here because I need to normalize the data before giving it to the model, and standard scaler does that. So it's time to build the neural network layer. So for creating the model, I have given the input dimension as 8, and I've given various dense layers starting from 16 to 128, and I'm using relu as my activation function. So here I'm adding one more dense layer with the sigmoid activation. It was my output layer since it was the last layer I gave. So here I'm using compile using the loss is binary cross entropy and Adam optimizer, and matrix is accuracy. Here is my model summary. We have total of 6 dense layers, and input shapes differ from 8 to 128, and the number of parameters in total were 11,321. There are no non-triable trainable parameters. So here I am fitting the model using X test and Y test. For the validation data, I am giving the batch size of 32 and number of epochs as 100. So for each step, the accuracy keeps increasing, and the validation loss also keeps increasing. So we have a loss we got a loss of 0.14, which is not bad, which is very good, and we got an accuracy of 94.6% and validation accuracy of 72.4%. So evaluating the model, we got the scores are 1.071 and 0.72. We are visualizing the training and validation accuracy and training and validation loss, which are nothing but these things: training and validation. So we can see the training accuracy keeps increasing, and the validation accuracy keeps remains the same, like it is stable. And when it comes to loss, the training loss keeps decreasing and the validation loss keeps increasing. So that's it from this task 1, and from task 2 we are doing the same, except we are changing the dataset. Here we are using breast cancer dataset. We have 569 rows and 33 columns, and since diagnosis is the column of class label, So we are changing the character values into digits. So I'm changing malignant and benign as 0 and 1. So yeah, we have the data set shape as 569 by 33 as we see here. So we're passing x train, x test, and y train, y test, except the class label from second row to second column to 32nd column, and we are giving test as the second column, which means this one, the diagnosis, and the test size was 25%. We are using standardized scalar for normalizing the data. So the same thing, we are giving the dense layers and the same activation functions as the previous one. Here also we are using binary cross entropy, since we have only two class labels, to like M and B. So the same thing, we are fitting the model here, and we can see the accuracy is 1, and the validation accuracy is 0.95, 95%. So we are visualizing using Matplotlib. We can see here the training and validation accuracy, which is so at the first sample itself it went up to 95%, and the training accuracy keeps increasing and the validation accuracy remains at 95%. When it comes to loss, the training and validation, there is no loss at all for the training, and the validation loss is 0.1 at the beginning and it went up to 0.3 at the end, which is pretty good. That's it from this ICP. Thank you.